Before we move into collision objects, I want to show you a very interesting thing that can be done with constraints, and that's animating constraints over time. So as I explained in the first video of this chapter, I want to wait a few frames before the building starts collapsing. And the best way to achieve this is by animating constraints. So let's dive into the DOP network. And you will notice here under the constraint network node, there's a third input that says constraint solvers. So what we can do is create a sub solver within this network, and inside this solver create the animation for the constraint. So just before I dive in here, I want to show you, if you select the output node and go to the geometry spreadsheet, you will find this relationships object, and if you expand its hierarchy, you will find this constraint network 1. Inside there will be a constraint network, and here you will find the geometry for that constraint network. And if you take a look at the primitive section, here you can find, for example, the attribute strength that we created, the constraint type and the constraint name that we also created. But an interesting thing is if you step forward in the animation, notice how a new group will be created. This is a primitive group called broken, and this is being created dynamically within the simulation. So what this group is doing is separating whatever constraint already broke and somehow deleting it from the simulation. So all this is internal, but we can use this knowledge to change the animation of these constraints within the sub-solver. So let's now connect the sub-solver to the third input and dive into the solver. So first of all, what we want to do is look for this object merge. This node was created for us, but what it's doing is merging in the constraint network each frame. So what we could do right off the bat is create a delete node and animate the bounding box to select the primitives that we want to delete. So let me go to the bounding volume, turn on enable bounding box, and change the size. So we know that 26 meters is enough to encompass the entire building. I'll just make it a little bit higher and create a few keyframes for the size and center. I will also turn off the simulation for now, and on frame 28 I will increase the size of the bounding box. So you can see that some of the constraints are being deleted, and of course, since this is animated, they will be deleted over time. So let me go up one level. For now, I will turn off the display for this geometry, just to see the constraints here. And I may also increase the strength, just so we can more clearly see the animation progressing. So let's again turn on the simulation, and let's press play. So still some constraints are breaking due to the pressure of the concrete. So let me increase even more the strength. Okay, so now we will start seeing the lower constraints will start breaking. And of course, if we turn on the display of the building, we should see it collapsing. Okay, so although this approach is valid and it can be used, let me show you something real quick. So remember, we had a broken group that is being created internally. What happens if we add another delete node? That will only affect whatever is in this broken group. So let's take a look what happens. Actually, let me go back and again decrease the strength of the constraints. So we know that some constraints are breaking with the pressure of the concrete. And here you can see those constraints. So right now, this is no different than what we had, but what I can do now is send some specific constraints that I want to break to this broken group, and that way ArtDirect when and which parts of the constraints I want to break. So first things first, let's decide which of the constraints we want to break. And if you remember, let me show you the geometry of the building. Let's go to frame 1. We were talking about breaking the parts of the building where we added the most detail, which is here in these columns and the columns of the second floor. So for that, I will create a box and encompass with this box the pieces that I want to break. So let's make it 26 meters in size, both in X and C. Maybe 2 meters in Y, and I will move it upward so it's centered with these columns. So you can press spacebar 3 to see the front view. So I think this is fine, and we will need another box for the second floor. So I can Alt drag this box to copy it, and then bring this box higher. Something like this. So now we can use a merge to join these boxes together. And what we can do is copy these nodes, go back into my DOP network, and paste them in the SOP solver. So let's make some room here. Actually, this node we don't need anymore. I will paste the box object, and we will use this geometry to create a selection of primitives. So let's drop down another group node. I will change its color and call this group, or GRP, kill. Select the group node, and if you take a look here under keep in bounding regions, enable this option, you will notice there's an option called bounding objects. So this bounding object is whatever is connected in the second input of the group node. Now it's erroring out because this technique only works with points, and here you can see points or vertices only. So what we will have to do is change the initial type or the group type to points, and then convert this group to a primitive group. So first of all, let's change the name of the group. We will call this group kill. And then we will promote or change this group type to a primitive. So the group is kill group, and change from points to primitives. Let's also change the color of this group and call it promote kill group. So this group by itself is not doing anything in particular, but what I'm going to do next is send whatever constraints are in this kill group to the delete group, but I will do it only after frame 24. And to do that, I will add a point wrangler, or actually an attribute wrangler, because remember, these are primitives, not points. Change the color of the wrangler and call it send to broken group. So in the wrangler, I'm going to use an if statement to evaluate if the frame has passed frame 24, and if that's the case, send whatever is in the kill group to the broken group. So type the following: if open parentheses at frame with capital F is greater than 24 and close parentheses, then you can open bracket and close brackets, and in between these brackets type at group broken is equal to 1, semicolon, and Control Enter to evaluate. So again, what we're saying here is if the value of the current frame is higher than 24, send whatever is selected here to the group called broken. So this equals 1 means add to this group. So let's press play and let's see what happens. Just make sure to display this last delete node, and we can also change its name to delete broken. And let's press play here. So in theory, after frame 24, the connection should break, and it's not happening. So let's take a look at the code, and it looks fine. Actually, the thing that's missing is we're running over points, and remember, we should be running over primitives. So let's try again. Yeah, now it's working. So after frame 24, all the connections that were selected will disappear. So initially the process may look a little bit complicated, but the only thing we're doing is retrieving the connections or the constraints, selecting a group of points, and then promoting those points to a primitive selection or a primitive group. This is being done with a group promote node. And with the wrangler, we're just saying whenever the frame is greater than 24, send this kill group to the group called broken. And everything within this broken group is being deleted. Let's finally just take a look from our camera view, and of course let's select the geometry or take a look at the geometry view. Also, let's change the shading and press play. So after frame 24, this part will break and the building will start collapsing. So there it is. And just remember, combining all these techniques, you will have a lot of flexibility and a lot of different ways to art direct your destruction.